Hey, here we go. Guys, continuing from yesterday's two-column proof. I know. Yeah. Hey, focus up here, please. Thank you. Hey, you guys, the given here, they actually have one piece that they didn't give you, at least in the statement. Picture-wise, they did. Anyone know what that is? Isaac? No, we can assume a straight line, but there's one point they've referenced on here that they haven't referenced in our given. KJ? Yeah, you have to, we should actually be saying that point S lies between point R and M on the line.
Does it bisect it?
It doesn't bisect, it's just point S lies between point R and M on line RT. Okay. So when you're doing your givens, M is the midpoint. Of RT. You don't have to do a whole nother line for given. You could just comma and then say a point S lies between points R and M on line RT there. Okay? All of that is given. All right. Number 2. Anyone? Maddie?
RS plus SM equals RM, and that's the addition property of equality.
Okay. RS plus SM equals RM. And that is what?
Addition property of equality.
Actually, not addition property equality. Yeah, Alexis. Yeah, that'd be the segment addition postulate. Addition property equality would say we add the same thing to both sides. A segment addition says, hey, this plus this makes that. Okay. Now, things that we haven't spent a lot of time on with this is if we're trying to prove that MT is equal to RS and SM, you should have a plan of attack. You shouldn't just kind of randomly go. It'd be like me saying, hey, let's leave here and let's go to Safeway. Okay, and then you're like, everyone just like scatters. Or better yet, maybe I say, okay, guys, I want to leave here and I want to go to Everett Public Library. Okay, how many know where it's at? How many have no idea where it's at? Okay, so if the majority of us don't know where we're going, but we know we're leaving here, and we go, okay, we'll see you guys there, and then I just leave, you're like, all right, well, I guess we should go. And like some of you go north, some of you go south, some of you go east, some of you go west. We're like, maybe if I just keep wandering in this direction, eventually I'll get to the library. Okay, and like, days later we find you kind of off on the side of the road, just kind of wandering around aimlessly. Like, what are you doing? Well, I'm going to the library. Well, I'm not sure where I'm going, but I know that I'm supposed to go somewhere. Okay, that's kind of what could happen with a proof. Okay, you could go, okay, I need to get to here, but I have no idea how to get to there. But I know I should do something, so I think I'll just start saying all these things that I can say about this. Sometimes that works. Sometimes it don't. I mean, there could be a chance you're like, well, Everett is that way, so I need to go across the trestle. And you end up just like cruising that way. And you just randomly find it. Some of you are like, Everett's really across the trestle? Yeah, man. If you've never crossed the trestle before, I'm just saying. on the other side, there's like a whole new world. I know. Okay. I'd bust out in song, but you guys don't need that. Maddie's. Okay, so maybe we should have, with that being said, maybe we should have a plan of attack. If we're trying to say MT is equal to RS plus SM, what is our plan? Like, how can we do that? Like, ignoring that we actually have to prove anything, okay, in terms of writing anything out, how could we actually, like, what would you do? You want to prove that this plus that equals that. Alexis? I'm just taking notes here. Show RM is congruent to MT. Okay, that's just like a quick synopsis of what she just said. Okay, now we didn't prove anything, but that's a plan. It would be like me saying, okay, guys, let's leave here, get out to the light, hang a left, go across the trestle. When you get across the trestle, turn right by Les, or take the exit by Les Schwab, turn left onto Everett Avenue, cruise all the way down, and then on the left at Rucker, you'll see the library. It's like me giving you instructions. Okay, this is your goal. If I can show that RM is equal to MT, and I know that RM is equal to SM plus RS, okay, then I know that MT would also be equal to SM plus RS. Make sense? Okay, so that's kind of a pretty basic one. So we've started that out. We said, well, RS and SM equal RM. That's good. All right. So now what else do I have to say then? If we look back at, yeah.
Okay, RM is congruent to MT because of the definition of a midpoint.
Okay, so RM is congruent to MT. Is the definition of midpoint? Tell your neighbor what you think. Will that work?
Emma DeFrang helped me with this. So.
Emma DeFrang helped you?
Yeah.
So that makes it all good.
Yeah.
Sammy helped me.
Oh, good.
But she got it wrong.
Okay, hey, will the definition of a midpoint actually show that two parts are congruent? Yeah, it will. Okay? So definition of midpoint. Okay, now what? Someone besides Maddie this time. Carson? MT is equal to, should be putting these, is equal to RS. Well, how do you get that? Where did you substitute? Okay, so we know that this and this are the same. Therefore, we can put MT, okay, since we know that those two are the same, right here. These two are the same. We can use substitution. Okay, good. Now, how many got that? All right. Did anyone put it in a different order? Is it okay to put it in a different order? The answer is yes. As long as, like, to use substitution, you have to state both of these things first. To use definition of midpoint, you have to state there's a midpoint first. Okay? If you don't state it, then you can't use it. To use point S, you actually have to say where point S is. Okay, so you have to state the given first in this one. And then you'd have to use definition of midpoint and angle or segment addition before you can use substitution. Okay, very good. Any questions there? A pretty good job. Yes, Mr. Hunter. Can I tell you what ZDD? Did you figure it out yet? No? What? What is it? No, they. Oh, well, do they? Oh, I don't know either. I do. I hope not. It's not. It's not zebras do drugs. Yes, Danica. Well, I want you guys to figure it out. That ruins all the fun. It's like saying, hey, there's a good movie coming out. Oh, yeah, it actually came out yesterday, and I saw it. Yeah, and at the end, like everyone just goes and they tell you guys the end.
Not telling us what the movie is that you saw.
Huh? I'm telling you, it's ZDD. All right.
Is it like how are we?
All right. Hopefully you'll come out with your. So on our assignment today on 2.5a and b, if you work through these kind of in the order they're given, I will try to give you guidance. We're going to skip those two, but number 5. So you have your givens. Make sure that as you're looking at this, you recognize that there are 2 different given pieces there. All right. So if I'm trying to prove that AFB is congruent to CFD, so this guy to that guy. That's what we're trying to prove. Okay? Anyone have a plan? Sam, you got a plan? Okay, so you have your givens. Does the given give you anything that isn't marked in the picture? Alex?
So something that it doesn't give is that angle CFE is right angle.
Okay, it doesn't tell us that. Yeah, so there's another given right there that they don't tell us in this statement, but is on the picture. So sometimes we have to take that. Like we know that based upon the picture, another given statement is angle CFE is a right angle. Okay, but when it says given BF bisects AFC, okay, when it says this bisects it, does that do anything does that give us any other information? Does it let us conclude something from that given information? Now, I'm not going to give you guys this. I'm not going to tell you what to conclude. Why don't you guys talk about it as a group? There's got to be a way for us to figure out when I say that, hey, this is a given statement. This angle right here bisects this angle right here. Okay? What's a bisector mean? What can we conclude? Talk with your group real quick. Okay, anyone have it? One person has? 2 people? About 3 of you? All right, KJ, what do you got? CF and AF. Nope, it's an angle bisector. But you're right, it does break something into equal parts. A bisector breaks 2 things into equal pieces. Yes, Drew. Good. It means this angle right here is congruent to that angle right there. That's the definition of an angle bisector. By definition of an angle bisector, this is congruent to that. Now, I'm just kind of going through the extra given pieces. I'm not actually going for a proof yet. Just saying, hey, they give us this, so we might as well mark it in here. We know that now. Okay? That's something we'd have to state later, but we know that. Okay, how about angle CFD and angle BFC? So we're saying angle CF and D and B, F, C. So this angle and this angle are congruent. So we could mark that, right? Now remember, this in here, these little markings down here, that's what we're trying to prove. Can anyone see their map on how to prove it now? All right. I'm not going to go any further. I'm going to let you figure that one out from there. Okay. Give it a go. Okay, can anyone tell me the last reason they used on that proof? I don't want to put the proof up there. How many are done with number 5 now? How many are still stuck on it? Okay, if I know that two things are congruent, if this is congruent to that and that is congruent to that, what's the property I can use? That is the transitive property. Use the transitive property to finish that proof up. Okay, if you're still stuck, you need to ask me. We're going to move on to number 6 here in a minute. All right. Hey, if you guys have not finished up number 5, or if you have and you haven't checked your answer, probably be better. There's what we have. We have our givens. We have that BFA is congruent to AFB by definition of angle bisector, so we know that this is congruent to that. And then based on the transitive property, if that's congruent to that and that's congruent to that, then this is congruent to here. Okay? So going back to it, if you were to call, you were to say, hey, that this is angle 1, and this is angle 2, and that is angle 3, really what they've told us is angle 1 is congruent to 2, and we also, angle 1 is congruent to 3, and angle 2, or 1 is congruent to 2, therefore angle 1 is, do I have that backwards? I think I do. I think I confused myself. Yeah. Okay, these two are congruent, and we have BFC is congruent to AFB based on angle bisector. They also tell us CFD is congruent to BFC, so 2 is congruent to 3, therefore 1 and 3 have to be congruent.
How many steps are there to number 6? What? Oh my, I'm just gonna check how many steps there are.
Okay, really that's what you're saying on that one. Okay, let's take a look at the next problem real quick. Number 6. Given AG bisects CD. How many of you started number 6? Tougher problem, man. Hey, given AG bisects CD, so we have this middle bisects this whole line. IJ bisects CE. BH bisects ED. Prove that this little chunk right here, KE, prove that that is congruent to FD. Got a plan? What's your plan? No, I don't want to hear the proof. I want to hear a plan. Like, what would your plan be rather than just like not knowing where to go? A lot of times the plan is the toughest part. Maddie?
If we can prove that CK is equal to EF, then that would make sense. AG bisects CD, that would make KE and FD congruent.
Okay, so if we can prove CK equal to EF?
Yeah.
All right. So how could we do that?
IJ and BH bisect CE and ED.
Okay.
So that would make them equal because CK and EF, because of the definition of segment bisector.
So maybe if we could prove like all of these little pieces in here congruent.
Yeah.
Okay. So rather than say we're proving CK is equal to EF, which is equal to EK, which is equal to FD. If we can somehow prove that all those little pieces are congruent, then we might be able to prove that, or we can show that these two are congruent. Yeah, that's easier said than done, though, right?
What's the definition of segment bisector, right?
Yep, definition of segment bisector will help you out here. So here, I'm going to give you the reasons you'll need for this proof. All right? Write them down off to the side. You're going to need definition of segment bisector. You're going to need segment addition postulate.
Is this in order?
No. You're going to need definition of congruent segments. The way I did it, you would need division property of equality. You would need transitive property. You would need substitution twice. And then you'd want to, I guess the other reason would be to simplify. Like you're just simplifying your expression. Which we don't always include that one. But really there's 9 parts to this proof the way I wrote it up. Yeah, dude. Total dang. Drew. No, not in that order. All right.
I'm just like saying that.
No, so you guys, the best case scenario, if you can start out, trying to prove that these pieces congruent, well, you have a bunch of bisectors here. Start with the big bisector. Then start with the smaller bisectors. Okay? And then from there, think about how the big bisector creates congruent parts, and think about how this big segment is related to these two smaller segments. Okay? They're not always easy. Give it a go, though. Start by putting down your given statements. All right. Well, let's go ahead. I'm going to cross that part out so we don't confuse ourselves. Actually, let me do it on a separate sheet of paper. Our statements, our reasons. All right. I'm not going to spell all that out, but first statement. What do we have?
AG bisects CD, IJ bisects CE, BH bisects ED, and that is a given.
Nathan, is that what you're saying? All right. So we have all of our given here. While I'm writing this down, you tell your neighbor what else that tells you. What can we deduct from that?
This is equal to this. This is equal to this. They're all congruent. This is congruent to this. This is congruent to this. This is congruent to this.
ED is congruent to EC, so those two are equal.
Do you have unnecessary steps, or is that the fastest way to get it done?
There could be other ways. That's just the way I did it. Sorry.
Because, well, if you know that they're congruent, then you can just say CK is congruent. Is this possible to do in 3 steps?
Well, here, let's go through it. So, if I have that, what else do I know? No, I'm not going with just 1 or 2 hands. Like if we're doing this as a class, we're going full participation. So everyone has to be in thinking mode here. Okay? So based upon knowing about segment bisectors, what does that tell us? When I have a segment that bisects a line, we should be able to key in that word bisect now. All right, we're almost halfway. Okay? Cool. Getting close. All right, Hunter, what do you got? Splits it exactly in half. So if BH bisects ED, it splits it exactly in half, which means if we just focus in on that piece, what is it? Which 2 parts are congruent? this is congruent to that. Okay, so we've got to start keying in on those terms. So we know that EF is equal to FD based on, what's our reason? Definition of segment bisector. Now, just so that we don't have to keep writing definition of segment bisector, we had 3 bisectors there. What else? What other parts are congruent then? Alex? Yeah, KE is congruent to CK. Now, does that... Oh, thank you. KE is congruent to CK. Does that mean that KE is congruent to EF? We don't know that for sure. We just know that this bisects this. So we know that that is congruent to that. It does not mean it's congruent to this yet, based upon what we said. Okay, so we could say CK is equal to KE. However, we have one more bisector. And that bisector is our middle one, right? And that middle one breaks this and this. So that says CE is congruent to
FD.
F. How about DE?
D. Oh. E.
CE congruent to DE.
That's what I wrote. I just can't read what I wrote.
We good there? So Abdul, what else do we know? Yeah, go ahead, help Carlo. CK plus KE is equal to CE. That would be helpful because if I can say that this plus this equals, or excuse me, this plus this equals that, and this plus this equals that, then I might be able to do something with substitution here, right? I know that CE, so notice here's CE, here's D. If, number 3, if I can say, well, CE is made up of CK and KE. We good there? Okay, and the benefit of doing that, if I use that there and then I say, well, DE, what's DE made up of? EF and DF, or FD. Okay? So I just kind of tagged along to your proof there. Is that all right, Carlo? That statement? I just kind of put my piece on there too. That's what you had. What reason did you use? Segment addition postulate. Okay? Segment addition postulate. How is that helpful now? Well, note that CE equals DE, and if CE is this, and DE is that, what can we say now?
Now can you say that K is congruent to FD? No.
Isaac? Can't quite go there yet. Alex?
That
CE plus DE equals CD.
Yeah.
Don't even have to do that. I don't know how I have it completely on the board. I'm not really following that. If C equals this, if C equals DE, and this is CE, and this is DE, yeah. Good. CK plus KE, so this has to equal that. What did we use there?
Substitution.
Yeah, use substitution. Is that what I have? I have the transitive property there. It's kind of using the same thing there. Okay. Number 5. So let's make sure we're clear now. Now we've said that this plus this equals that plus that. Cool? Yeah. Okay, hold on. Let me pause you real quick. I think right there we just started losing people. Hey guys, let's go back to what we're trying to prove. We're trying to prove this. Everyone good there? Okay, notice what that's this piece equal to that piece. I have it in backwards order. What do I not need anymore? I want CK and EF gone. Right? Well, what's another name we have up here for CK? KE. So let's use that. Let's say, okay, well, CK plus, let's make KE become, or excuse me, that's CK. Let's say let's make this KE. KE, we're substituting, since CK equals KE, we're saying, hey, CK can be called KE. So KE plus KE equals, what's another name for EF? FD. Okay, well, we could call that FD plus, we're going to switch this around, call that FD as well. You guys with me? What did we use there? Substitution. All right, now, how many KEs do I have? 2 KE plus, or equals, what here? 2 FD. What did I do there? I simplified. Now it's straight algebra. Because really, what do I not want anymore? The 2's. How do I get rid of 2 on both sides? Good. Okay, KE equals FD based upon division property of equality. That is our statement we wanted there. And actually, I guess the last piece, the actual statement says congruent. Mine says equal. This is talking about lengths. When you say, pause for a minute, this is talking about lengths. This is measurements. Stop shuffling. Stop. Stop shuffling. This is talking about measurements. This one is, excuse me, this one's talking, this one's talking about measurements. This is talking about a picture. FD. Or excuse me, the congruent symbol is the picture. So we need to make one more statement, technically, and say, okay, KE is congruent to FD. Okay? And that's the definition of congruent segments. That way it's exactly what they wanted there. Yeah. Okay? You guys have to do one of the proofs on the back tonight.
Only one?
Pick one. If you want more practice, you do more.